Lesson 102, number 18. I started it and then got a little interrupted, so we're going to resume it. Where is it? 18. Okay, so it says triangle has 50 degree angle, so I wrote that there. It's supposed to say 50. And an adjacent side is 9 and the opposite side, adjacent side is 10, opposite side is 9. Draw the triangle or triangles described and find the lengths of the sides. So this is one of the ambiguous case problems. You could either have 0 triangles, 1 triangle, or 2 triangles. To have 0 triangles, that would be if this leg, or if this side were shorter than the height, then it wouldn't reach, right? It wouldn't reach. So we want to check and make sure that this is at least as long as the height. And so the way you check is you can use your SOHCAHTOA because that's opposite and that's hypotenuse, so it'd be sine. Turns out this height is 7.7, so this is going to be able to form 2 triangles. If this were bigger than 10, it would only be able to form 1 triangle because it wouldn't be able to, it'd be so long it wouldn't be able to swing around. But this can form 2 triangles, so if you imagine it swinging around, well, that doesn't look right, but see, like if it swung around, then it could get this other triangle. So I drew the other triangle right here. Okay, they both have the same sides because this angle up here is not fixed and the side down on the bottom is not fixed. I wrote X for like this side length. So now we have to find, we want to find the side length, so we can use law of sines right here. We can say sine of 50, or what am I doing? Yeah, sine of 50 is to 9 as, well actually I need another angle now, don't I? So we will use law of sines, but we need, let's see if we can get this angle right here. So, so we'll go sine of 50 is to 9. We're going to have to get this angle. And then we'll go 180 minus that, and we'll get that. So sine of 50 is to 9 as sine of, I'll just call it theta, is to 10. So it's kind of a roundabout way of doing it, but we don't have much choice here. I'm not in love with this calculator that I have. I'm going to get my good calculator. Here's a good calculator. Okay, so 50. So this will turn out, if I use cross products on it, this will be 10 sine of 50 over 9 is going to be sine of theta. So I'm going to inverse sine both sides. Alright, then I'm gonna inverse sine that, so shift sine answer equals. So I got 58.33 or 58 point, maybe I could call it 58.34. That's not the answer. I'm just boxing it in so it doesn't get lost in the mess. That's 58.34, the acute angle. Now this angle right here is actually going to be 180 minus that number. So 180 minus 58.34. Obtuse angle, this obtuse angle. This is 121.66 degrees. So for when I'm solving this triangle, I'll use that. Okay, so, but right now, I've got this is 58.34, so I know 180 minus 50 minus 58.34 is going to give me the angle that I need, the one that I want, which is this right here, 71.66. I want that angle so that I can use it as a pair across from the side, because that's what the book is asking us to get this side. I've called the side X. So now I finally have the angle I can use, so now I can actually do my calculation that I wanted to do before. So I'm going to say sine of 71.66 is to X. Cross products, that's going to give me 9 times sine of 71.66, divided by sine of 50, that's going to equal X. I got 11.15. And do I even have any units on this thing? I'm just going to write units. So the one with the big cloud around it, that's the actual answer that they're asking for. Okay, now we're going to do, but there's two answers, right? Because there's the two cases. So, so over here, we're going to kind of do the same procedure, solving for X, but we're going to get a different angle up here. So we'll go 180 minus 50 minus 1.66. It's going to be a really small angle. This little angle is only 8.34 degrees. Okay, so now I can go sine of 50 is to 9 as sine of 8.34 is to X. So cross products, 9 sine of 8.34 divided by sine of 50. I got that little tiny number. That seems about right. 1.7-ish. And there's your two answers.